All right, so what we want to now look at is a linear equation in three variables. The same way that we can graph and identify points in the two-dimensional, and we see that we could do that in the three-dimensional realm, then therefore we can also write an equation in three variables that can be represented in graphical form on a three-dimensional coordinate grid. So a linear equation in three variables, x, y, and z, is an equation of the form ax plus by plus cz equals to d. Now a, b, and c are not all zero, right? That has to be the case, or else you don't have a three variable equation. An ordered paired or ordered triple rather, x, y, z, so the x, the y, and the z's represent your points, is a solution of this equation if the equation is true when you substitute the values into the equation, just like you would with a two-dimensional. So that means we can graph this in a three-dimensional figure. All right, so now let's look at an additional example here. We're going to graph a linear equation in three variables, and we're going to use the x and y and z-intercept form. So the same way we find the x and y intercepts when a linear equation in a two-dimensional graph is in standard form, we could do the same thing with a three-dimensional. So if you have 2x, right, setting y equal to 0 and z equal to 0, right, this finds the x-intercept. So we have 2x plus 4 times 0 plus 5 times 0 is equal to 20. And that's just going to give us 2x equals to 20, and therefore x would be equal to 10. Right, we could do the same thing with the y-intercept. We want to see where that crosses. We set x equal to 0. We'll look for the y value, and then set the z equal to 0. And once we do that, we're going to get 4y equals to 20, and therefore y will equal to 5. And then the last one, I might have to use this space over here. To find the z-intercept, what we're going to do is simply set everything else, x and y equal to 0. And remember, when we set equal to 0, that brings us down to where that value touches the other axis, the one that is not set to equal to 0. And so we will have 5z equals to 20. We're going to end up with that 5z equals to 20, and dividing both sides by 5. Remember, on each side we're dividing. We're going to get z equals to 4. Now that we have that, we simply need to find where these points touch the graph. And so each of these points where the x-intercept is going to represent x, or our x value in this case is 10. So we're going to have 10, 0, 0. And we're going to go ahead and plot that point. So 10, 0, 0 is the point that we have there. And I'm going to have to go by 2's to fit that in there. So 2, 4, 6, 8, 10 will be here. Right, so that represents our first point. I'll use x's again. This is hard to draw a point or dot with my screen pen. So we have 10, 0, 0. And then for our y-intercept, we're going to have 0, 5, 0. And then we go ahead and plot that in there for our y-axis. Remember the y is that horizontal. We're going by 2's, so 2, 4, 6 is 5 would be halfway in between there. And then the last one, our z-axis, is going to be 0, 0, 4. And so we go up to 4. We're going by 2's just to fit the 10 in there. And once we do that, we simply connect the points. And so if I was to connect these points as follows, you want to use a ruler, and that would represent our graph. And if I was to just kind of shade that in there to represent the plane that's being connected. All right, and that's how you would do that one. We go ahead and do part B there. I'm just going to need to erase my working. Okay, so we're going to do the same thing with B. In order to find the x-intercept, right, we're going to set everything else equal to 0 except for the x. So that's 3 times 0 plus 7 times 0 equals to 21. That's going to leave us with 3x equals to 21. Dividing both sides by 3, we're going to get x equals 7. So we've got 7, 0, 0 for the x-intercept. For the y-intercept, to do that one, we just set everything else equal to 0 except for the y. So we have 3 times 0 plus 3y plus 7 times 0 equals to 21. we will be left with 3y equals to 21, and therefore dividing both sides by 3, y will also be 7, and we have 0, 7, 0. Then the last one, utilizing this space over here on top in the coordinate grid of part A, our Z-intercept is going to be setting everything else equal to 0. And that leaves us with 7z equals to 21. Alright, so we have 7z equals 21. Dividing both sides by 7, we will get z equals to 3. So we have 0, 0, 3. Then we can just go ahead and plot those points. For the first one on the x-axis, I think we go up to 7. 1, 2, 3, 4, 5, 6, 7. Yeah, on both of them. So on the x-axis, if we go to positive 7, 1, 2, 3, 4, 5, 6, 7 would be there. And 0, 0 for the others. For the y-intercept, 1, 2, 3, 4, 5, 6, 7 as well. We'll go there. And then on the z, 1, 2, 3. Remember to just simply connect the lines, use a ruler. So if we connect those lines, straight lines we want to use using a ruler. And then we could just shade that triangular region in. And we see it also lies in the first or the positive coordinates, right? And so you could kind of consider that like this triangular canopy that's coming over that area. Now sometimes we need to transform or translate our three-dimensional linear equation into a two-dimensional function. So a linear equation in x, y, and z can be written as a function of x and y. Now to do this, what we do is solve the equation for z, then replace z with f of x, y. And this comes from page 173, numbers 13 and 14. If we wanted to write the linear equation as a function of x and y, we're going to follow those steps. So first thing we want to do is solve for the equation z. So if we do that, just bring everything over. We could bring it all in one step by just subtracting everything at once. So minus 6x, minus 6y on both sides. Right, so minus 6x and minus 6y. Just to knock them out faster, we're going to have 3z is equal to negative 6x, subtract 6y, plus the positive 9 that was already there. Then just divide everything by 3, right? Divide everything by 3. You could do that individually or written collectively, but negative 6 divided by 3 is going to give us negative 2x. The negative 6y divided by 3 is going to give us negative 2y. And then 9 divided by positive 3 is going to give us positive 3. So now that we have that z there, one little thing we need to do is simply rewrite z with f of xy. Right, so this just represents that it's a function of x and y, right, because z is the vertical axis. So then we have negative 2x subtract 2y plus 3, and we're done. But the question does ask us to go a little bit further and to evaluate f of xy when x is 1 and y is 2. And so if we do that, if we substitute those values in there, we're going to have negative 2 times positive 1, subtract 2 times positive 2, plus 3. And doing that, we can find the z value, because remember, f of 1 and 2 is also equal to z. And so negative 2 times 1, it gives us negative 2. That's a subtraction sign there. 2 times 2 is 4, plus 3. And if we simplify all that together, negative 2 subtract 4 is negative 6, plus 3 is negative 3. So that means we know what our coordinate points is. So if I had to interpret this geometrically, I can say that my function of the graph contains the point x is 1, y is 2, and z negative 3. And that's how you can actually translate them from a three-dimensional to a two-dimensional if needed. All right, so let's do number 14 just to make sure we truly understand it. Remember, the first step is just to solve for z. So solving for z, just in like one step, we could bring everything over, plus 2x and plus the positive y. Cancels on that side, we have a positive z. Then we're going to have positive 2x plus a positive y plus 7. We're technically done. We just need to rewrite that z with f of xy to say that it now represents a function of x and y. Now if we were to do that last step, we'll simply substitute those values in of negative 3 and 2. And so that means where we have an x, we're going to have times -3. And where we have a y, we just substitute the y in there. All right, so when we simplify that, 2 times -3 is -6. -6 plus 2 is -4. And -4 plus a +7 will give us a +3. And so remember, that function is really the variable z. So that means we know what our value of z would be as well. And so we can simply now rewrite that answer. And if we needed to, write our coordinate points. We know that our three-dimensional coordinate point there would be -3, 2, and 3 would be a coordinate point of that function.